My name is Drazen Dujic. I'm an electrical engineer by education. I did my PhD back in 2008 in Liverpool, England, dealing with multi-phase modulation methods for multi-phase machines, actually. Then I came to Switzerland, and I was with ABB Switzerland in a research and management role for around 5 years. And since 2014, I've been with EPFL as a tenure-track assistant professor, now as an associate professor in a power electronics laboratory. And what we do here, it's all related to high-power, medium-voltage conversion technologies for various electrical applications, installations, utility sector, renewable energy generation, or generally topic of electrical energy conversion. What is power electronics? In a very simple sense, everything we do is related to electrical energy conversion from AC to DC, from low voltage to high voltage, from three-phase to single-phase, from three-phase AC to high, low, medium voltage DC. So as such, the work done in power electronics is pretty much present everywhere nowadays in the lives of people, much more even than they understand. From chargers for mobile phones, laptops, to power supplies, to electrical vehicle charging, to converters in between battery and a motor in a vehicle, hydropower applications between a generator and the network, wind turbines between a generator and a network, photovoltaic installations between a photovoltaic panel and an AC network. All of those boxes are essentially power electronics converters performing electrical energy conversion role. Since establishing Power Electronics Laboratory and joining EPFL in 2014, we have been collaborating with various industrial partners. Pretty much any industrial partner looking for technology development in the domain of power electronics. We have been in contact with the Korean industry, German industry, Swiss industry. At the same time, there are several European projects that we were involved into, mainly addressing new technologies that will come up, either in a currently ongoing X-Flex hydro project where we deal with the hydropower applications, or in a Hyperride, a European project where we are exploring hybrid AC-DC microgrids, which will basically serve certain specific applications. In all of these cases, our focus is always on the electrical energy conversion by basically means of power electronics. So to realize power electronics converters, we rely on many technologies from various different fields, from mathematical analytical tools to model, design, optimize our systems. We rely heavily on semiconductor devices, which are being developed greatly in recent times with the wide bandgap semiconductors, which are really changing the performances of power electronics converters. We rely on magnetic devices. There is almost no converter in the world without inductor transformer of any kind of sense. So mastering magnetic design is of high importance. And finally, for a converter to perform and serve the applications, there is a need to develop a control system which will manage everything fastly in a real time with precision, basically maximize the performances of all of those elements installed in the converter. To answer the question where technology will take us, we are witnessing lots of development recently, the large deployment of renewable energy resources, mainly hydropower, photovoltaics, wind generation. All of that heavily relies on power converters as an interface between a prime source of energy and the network on one side. We see a huge transformation of mobility sector with electric vehicles, and that's again impossible without power electronics converters designed and optimized and inserted between the battery and propulsion motors. And all of this is driving, there are many driving forces, but there is a desire to improve performances of conversion technologies, to make them more affordable, cheaper, more efficient, more compact, especially when they are serving mobile applications. There is a need to realize lots of power in a small contained space. This drives really research forward quest to make more power dense conversion solutions to serve basically emerging applications.